Now let's see the next chapter, work power energy. Here we are going to discuss about work, power and energy. The three terms we are going to discuss now here. Different cases. Let's understand first one by one. First, work. What is meant by work? Work. Work means what? Tell me now. Generally, in the normal sense, if you are doing any, yes, you are just seated. You are doing something. You are writing on this thing. Then what we'll call in our the general English, we are doing some work we are doing. If you are doing some activity in a laptop, mobile you are doing, then that means that is considered as a work. You are doing some work you are doing. But in the physics, work definition is different completely. When there is a work is there, if there is a displacement is there, then only work is there. If there is no displacement, you are seated and you are doing something. That means whatever you are doing, even though you are doing some work you are doing, that should not be considered as a work in the physics sense. Okay. So when a body possesses displacement due to the application of force, then work is said to be done on the body. Then only we can say work is said to be done on the body. If there is a displacement of a body, then only we have work is done. Remember. How this work is done here, work is defined as the work which is given as, let us say we applied some force, we applied on the body like this direction. And this is the force. This is the force we are applying now here. Then this force we are resolving into two components now. This is one component F cos theta, and this is the another component. This is what you tell me now, F sin theta. And so let us say the body has been displaced from here to here. The displacement of a body is S. Then the work done, how it is defined as W will denote this work done, which is the component of force along the displacement. So the displacement of a body is right side like this now, and this direction, how much the force component is there? That is F cos theta. F cos theta is called it as, this is along the displacement now. So then we can write it as what will be now F cos theta into what will be now displacement of the body. How much the displacement now here from here to here? That is yes. This is called as a work done. F cos theta into yes. Now this can be also written as, yes, we can say this as Fs into cos theta, where theta is the angle between the force and the displacement. Theta is the angle between the force and displacement. Now this we can write the vector form. Force we can write it as a vector form, and that is given as what you tell me now. This is F bar dot S bar. Or we can say now F bar dot S bar. If F and S values are given in the vectors, then work done is given by what, tell me now? F bar dot S bar. This is a work done. Okay. And work is a scalar quantity. What is the work is a scalar quantity? Right. And units of work. The units of work, we have different units for work. The units of work, SI unit. SI unit for the work, which is equal to what, tell me now? That is a joules. SI unit, which is equal to joule. And CGS unit. CGS unit is erg. Erg, ERG. CGS unit is erg. 1 joule. 1 joule equal to 10 power 7 erg. 1 joule equal to 10 power 7 erg. 1 electron volt. Electron, that is one of the unit of the energy. What? Volt. Volt, V-O-L-T, volt. Electron volt. 1 electron volts, which is equal to 1.6 into 10 power minus 19 joules. And we have the other unit, we have 1 kilowatt hour. 1 kilowatt hour, KWH, kilowatt hour, which is equal to 3.6 into 10 power 6 joules. 1 kilowatt hour. And 1 calorie. 1 calorie equal to 4.18 joules. And while doing calculation, we can consider this as approximately as a 4.2. We'll consider, will do. These are the units of work. Yes, as of now, so remember here, joule and try to remember. Remaining units also will come one by one. Next. And this work, it may be a positive, maybe a negative, maybe zero also. Work may positive, maybe negative, maybe zero also. So you can see now here. So what is the work formula? Yes, so that means which is equal to Fs cos theta. Where theta is what you tell me now? Work which is equal to what, tell me now? This is Fs into cos theta. Where theta is what? Angle between force. Now let us say if theta equal to 90 degrees, then what happens? If theta is 90, what happens? Theta is 90. What is the cos 90 value? Then cos 90 is a 0. So that means what is the work will come now? 0. Right. And if theta lies between 0 to 90, if theta lies between 0 to 90, then in this case, cos theta value between 0 to 90 is a positive. Cos theta from between 0 to 90 is a positive. So we'll get the cos theta positive. That means work will become positive now. Then the work is positive. Next. Now here if theta lies between 90 to 180, if theta lies between 90 to 180, and how the cos theta value tell me now? Which is negative. Cos theta negative means how much is work you tell me now? Negative. So that's why work may be positive, may be negative, may be zero also. When it is positive, if the theta lies between 0 to 90, positive. If the theta lies between 90 to 180 is a negative. 0 for when theta is 90. And so here theta not only 90, some other cases also work is 0. In which cases work is 0? You can see now here. If the force is 0, work is 0. Fs cos theta, F0, work 0. Next, what else you can see now? Theta is what now? Angle. If theta 90, that means if the force is perpendicular to the displacement, angle between force and displacement is how much? 90 degrees. Right. So just imagine now here. So you have taken one object, you have taken now here. So you are lifted the object like this and we are moving like this. Then in this case, what happens now here? Your force is upward directions. And then you are moving like this. Force is upward directions and you are moving horizontally, you are moving. Then in this case, how much the work, what is the angle between the force and displacement now? 90 degrees. So in that case, work is how much? 0. So when a coolie travels on a horizontal platform with a load on his head, he is moving. So load is on his head and he is moving horizontally. How much the angle is a? 90. That's why work is 0. And in case of circular motion, so that means how should be the motion of a body? Circular motion, force. And the force which will act for the circular motion, and the particle will move like this. The displacement is like this now here, and force is like this now. Angle between the force and this displacement is how much? 90. In this case also work is 0. Now let us say we have some heavy object we have taken now. So heavy object, we are applying some force, we apply it. So then will this block will move? This block does not move. That means the displacement is how much? 0. Displacement 0 means work is also 0. Okay, in how many cases the work is 0 you can see now? When F0, work 0. If S0, work 0. If theta 90 also, work is 0. Okay, these are some examples when the work is 0. Right.